Hello everyone, so my name is Lakshay. I welcome you all to the discussion of AIATS plus mock test 3 phase 2. In this paper, we will be dealing with the organic section. यहाँ पे हम क्या डिस्कस करेंगे? We will be dealing with the organic section. The chapters were alcohol phenol ethers, aldehyde ketones, carboxylic acid as well as amines. So let us start with the question number first. Okay. From the question number 71st, we are given an alkyl halide as well as an alkoxide. So, as far we know that this reaction is simply a synthesis of ethers. We can say that this reaction is simply a Williamson synthesis. Just a second. This reaction is Williamson synthesis. So in this reaction, what we are gonna do, we have to take an alkyl halide. Let us say you are having Rx, and along with it, you will have to take an alkoxide. Let us say you are taking R-O minus Na plus. So the reaction is carried out in the presence of a dry ether. So you are taking dry ether. And if you are not taking the dry ether, this molecule will react with water molecule in the presence of atmospheric vapors and it will form an alcohol. So it is very necessary to take in dry ether over here. So after this negative charge RO minus will undergo an SN2 reaction over here. And it will undergo SN2 reaction, molecular substitution reactions, and it will form R-OR, and this is the final product we are getting over here, and this is simply ether. So let us take some examples so that this portion can be clearly understood by you all. So let us take some examples. Let us say you are taking CH3Cl in the presence of you are taking an alkoxide. Let us say you are taking tertiary butoxide, sodium tertiary butoxide in the presence of dry ether. So what will be the case? It will be the same, that this negative charge will undergo a substitution reaction over here and leaving behind the Ca from here, and you will get an ether. This will be the final product over here. But always remember, if you are changing the substitutions here, let us say you are taking the alkyl halide in this manner, if you are reacting with CH3 minus O Na plus. So now what will be the case? Here the Williamson synthesis will not be followed. And why is it so? This is only because this alkyl halide is tertiary, or we can say that this is a very hindered species. So SN2 reaction cannot be favored over here. And what will be the case? It will not be an attack over here and will not form an ether. And it will not form ether. So this will not be a Williamson synthesis. This is the Williamson synthesis. I hope this is clear to you all. Good morning everyone. Okay, let us get back to the question part. What does it say? We have this question. This is same question that we are having CH3Cl along with we have sodium methoxide CH3O minus Na plus. And now this negative charge will attack over here and undergo SN2 reaction in the presence of dry ether, and you will get, what will you get? You will get CH3O, CH3. This will be the final product of this question, bhai. I hope this is clear, and option 1 is the correct answer. I hope this is clear to you all. Shall us move to the next conceptual question? Okay, let us move to the next question. Okay. Question number 72. Which of the following will give aldol condensation reaction? Okay, this is a very, very important concept you need to understand before going this. As we all know, the aldol reactions, who will show it? The carbonyl compounds can show the aldol reactions, but none of all the compounds can show. There is a specific criteria in order to deal with this reaction. And what are they? We will try to understand each and everything. Firstly, in aldol reaction, it can be shown by carbonyl compounds. But all the carbonyl compounds will not show aldol reaction. There is specific criteria of the compounds which will show aldol reaction. What are they? There is a specific criteria that the carbonyl compound must be having alpha hydrogen. Must be having alpha hydrogen. Only those compounds which are having the alpha hydrogen can show the aldol reactions. So let us get back into the detail of this portion. That let us say we are having CH3. This is a molecule. Okay, so if this position is this is a function group, and the carbon atom which is attached to function group is an alpha carbon, and we can clearly say that this alpha position is having a hydrogen atom. It means this can show aldol reaction. This can show aldol reaction. Let us take some other examples, like let us say if I have given you a benzaldehyde, will it show the aldol reaction? Obviously not. It will never show aldol reaction because this is a function group carbon, and the carbon which is at the alpha position doesn't have any kind of hydrogens, so it will never show a aldol reaction. So this will not be the case. Let us take some other examples. Let us say we have taken the benzophenol. Can anyone give the answer? Will it give the aldol reactions? Is it? This will not show aldol reaction because this is not having an alpha hydrogens. So let us get back to the portion. See, we are taking aldol reactions here. And as soon as we proceed, we will try to get back to the condensation part. Okay, let us see. We have to take a mechanistical approach before dealing with this question. Let us say you are having this CH3. Let us check we are taking this. And this is a substrate over here. This is a substrate, and we are reacting with a reagent. We are taking with a reagent OH minus. And always remember, the base we are taking is a dilute. This is a dilute base, or we can say that only 30 to 40% is the concentration of this base. So what will be the case? The first case will be this is a base, and this will act as an acid because of the having alpha hydrogens. We can write it in the form like this. This is a hydrogen, this is a base, and this base will abstract this proton. And what will you get? You will get CH2 minus C double bond O and H. This will be the case. And the carbon ion formed is resonance stabilized. This negative charge will come over here, this can go over here, and you will get a resonating structures, double bond C, O minus and H. This is itself a stable species. Or we can say that this is an enolate compound. So can we say the step one is a formation of enolate ion. I hope this is clear. Okay, and now you have to understand that in the solution, now you have an initial substrate. Along with this substrate, you are having this anionic species. So let us consider both together, and you will get step 2. Initially you are having a substrate. Let us say you are having this substrate, and now you are having an anionic species O minus. This is enolate. What is the possibility over here? This negative charge will come and delocalize itself and will create a more electron density at this carbon, and now this carbon will attack at this position. This is a purely electrophilic case, electrophile, and this is nucleophile. We can clearly say that this reaction is nucleophilic addition reaction. This is nucleophilic addition reaction. So what will be the case? The product form in the manner you are having CH3, CO minus, having the hydrogen over there, and you will get CH2, C double bond O, and its hydrogen over here, and you will get this product. And always remember, in the previous case, you have released the water, and the water molecule will react with this, and this negative charge can attain a proton, and what will you get? You will get CH3OH. The hydrogen is initially present, double bond O and H. This is the final product of aldol reaction. This is a product of aldol reaction, not of condensation. Always remember. So what will be the product? This will be the alpha position. This is the beta position, and the product formed is known as beta hydroxy ketone or aldehyde. You will get the product over here. And if anyone will ask you, so what will be the aldol condensation product? So simply what you have to do, the base is initially present. So let us say you are taking OH minus. So there will be the two cases. The first one is this can abstract over here, and there is a presence of hydrogens also. So this can abstract this or this. If it can abstract this, this negative charge will take a proton intramolecular reaction and will form a negative charge over this position. And the negative charge created will transfer to this, and removal of OH will take place. And ultimately, you will get CH3. There will be the double bond O and H. This is the final product of aldol condensation reaction. I hope this is clear to you all. Yes, Pranika, there is a shortest method, but this is a mechanistical approach you need to understand before dealing with the questions. Okay. So this is the product formation. So always remember, Aishwarya has given the correct answer that for aldol reaction, there can be a possibility that only one hydrogen can be there to carry out a reaction. Or we can say that the aldol reaction can proceed. But if anyone asks you about the condensation product, so the aldehyde or ketones must have at least 2 alpha hydrogens in order to carry out a condensation product. Is it clear? Okay. So let us discuss about the shortest method, then we will get back to the question part. Let us see. I have given you again the same. It's CH3. Okay. So as we have discussed that 2 moles of this substrate can be utilized in the aldol reaction. So what will be the case? So just write the 2 substrates simultaneously in the structure, like write in the form that this is the position, and you are reacting it with base, and you are reacting with base. So these 2 hydrogens will eliminate 1 oxygen, and you will get a desired condensation product. So this is the shortest method, and the product will be formed. These 2, we can say that there will be the 2 hydrogens, 1 over here. These 2 hydrogens will remove an oxygen, and you will get C double bond OH, double bond CH3. This is the final condensation product. This is the final condensation product. I hope this is clear to you all. Okay, let's back to the question part. What does the question suggest? Okay. We are asked which among the following gives aldol condensation reaction. As we have discussed, for the aldol condensation, there must be the presence of at least 2 alpha hydrogens at the carbonyl center. So let us discuss about the shape so that we can clarify which is having the alpha hydrogens. The chloral, the structure of chloral is like CCl, Cl3, C double bond OH. This is the alpha position, and this alpha position doesn't have any kind of alpha hydrogen. So this will never be the case. So this option is ruled. Moving to the next portion, we have benzophenol. And the structure of benzophenol is, we have already discussed, like this is the structure of benzophenol. And we can clearly say that this alpha hydrogens will not having any kind of alpha hydrogens, so this will also not be the case of aldol reactions. Okay, so this option also ruled out. Let's move to the next option. We have methyl ethyl ketone. We can say that this can be C double bond O, CH3 over here, CH2 and CH3. So you can clearly say this is having 2 types of alpha hydrogens, the first one of this and the second one of this. And you have 2 hydrogens, it means it can show aldol reaction as well as aldol condensation reaction. Is it right? So this reaction, this will be the answer of this reaction. Okay, let us check the other options so that we can clarify it. You have 2,2-dimethyl propanol. So what is the structure? Its structure is like this. So we can say that this is the alpha position, and this alpha position does not have any hydrogen, so this will not be the case of aldol condensation. So this is also incorrect. So the our final answer is methyl ethyl ketone. Is it clear? Okay, crotonaldehyde, that's absolutely correct. Okay, shall I give you a simple question so that you guys can try? Okay, let me give you a simple question. Okay, let me delete a slide for you. Let us say I have given you let us say you are having C double bond O this, and you are reacting with a base. It's a dilute base. So what will be the product you are assuming? Aishwarya is asking what will be the products which alpha carbon will be attacked, and this will be the case of your question, bhai. Please try to attempt it. Meanwhile, I can try to give you an approach how to deal with these questions. So what is the product of this? Can anyone? Okay, let us discuss the same. Okay, now if we move to the simplest approach, जो मैंने आपको I have discussed about the shortest method. So what I have told you, just write the double bond this in a structure like these 2 hydrogen will be in the resemble with oxygen. So the first case will be the product like you are having C double bond O, CH2, and double bonded it's C this. This is the first product you can assume of the final condensation product. But there is a second case that there is a presence of other alpha hydrogens which can attack to this position as well. So what will be the case? Let us make a product of this using this. So if these two, this is a base, and this can abstract a proton from it, and you are hitting it, it means you are having the two abstraction proton conditions. There is a one condition, the second one is of this. So which will be the case? So which will be the case? The first will be the case, because it will lead to the formation of more stable enolate. This will be via 1, and if you are attacking the second position, you will get double bond O minus this. This is the second. And you can clearly say that the first one is more stable as compared to second. You all guys have understood why is it so? Because you have taken the class of the GOC by Pankaj sir. If you are not, so please after this class you can visit the YouTube channel to see the GOC ka Taj by Pankaj sir. You can clearly say that which of the enolate will be more stable. No, there will be no steric interest regarding here, because we have to say which enolate is more stable. This is having the more alpha hydrogens, so it will be more stable, more stabilized. So first one is more stable. So now when this negative charge will come over here, this will create a negative over here and will attack to other, and will attack to this and form the product. Absolutely correct. Which portion do I have to repeat? Okay, this is the simple case. If you have make the first one, it means this is more stable, and it will create a nucleophilic center over here, and this nucleophile will attack at this electrophile, and you will form a product like this. Is it clear? Is it clear, guys? Shall we move to the next? Okay, let us go to the next conceptual part, and if the time permits, we will discuss some more question of aldol reaction after this. Okay, so let us discuss some other questions. Okay, you are having question number 73. Among the following, most reactive compound towards a nucleophilic addition reaction is. This is one of the most easiest question you guys need to attempt it. That if let us say we have taken an example. Let us say you have taken this hydrogen. Let us take the CH3, and now you have taken CH3, CH3. We can clearly suggest that which is more electron deficient. The carbonyl compound which is more electron deficient has a tendency that the negative charge or nucleophile can attack that more electrophilic center. So this CH3, this is not the clear picture of it. It can exist. We can make a structure like O minus. This is positive. This is CH3. CH3. This is not a clear structure, but we can pre-assume it, which is the electrophile over here. So it means this is an electrophilic center. This is an electrophilic center, and that electrophilic center is more stabilized by these groups. We can say that they can show the inductive effect over here. So more will be the stabilization, more or lesser will be the nucleophilic addition rate, because this electrophile is more stable. Okay, so now here you are having more deficiency, that O minus positive, this is H, this is CH3, more electrophilic, lesser will be the electron sharing, more deficient, so nucleophile can easily attack over here to yield a product. So let us check the options. Shall we? Okay, In the first, we are having ethanol. What is it? You are having C double bond OH. This is ethanol. This is the first one. In the second, you are having propanol. This is propanol. In the third position, you are having propanone. This is propanone. This is second. This is third. Or we can say that this is acetone. And the fourth one is butanone. This is butanone. And we can simply say that the first one is more electron deficient because it is having only one CH3, it is having the inductive effect of 2 carbons, having the plus I effect of these, and having this, which will make a kind of hindrance, or we can say that lesser will be the electron density, or we can say that more will be the electron density at electrophilic center, which make the less rate of the reaction for the nucleophilic addition. So the option 1 must be the correct answer. Is it? So ethanol is the answer of this question. I hope this is clear. Is it? Shall we move to the next part? Okay, let's get to the next question of this paper. Okay. We have a question number 74, and it suggests that the compound which will not react with benzene sulfonyl chloride. This is a very important reaction in the complete chapter of amines. This is very, very important equations. Let us see. You are having, let us discuss the first structure of benzene sulfonyl chloride. So, if anyone will say that you are having this is benzene and this is sulfonyl chloride. This is benzene, sulfonyl chloride. Can anyone give me the another name of this compound? Which kind of reagent it is? The name of the reagent is? Can anyone? This reagent is known as Hinsberg reagent. Remember? Yes, this is not an Heisenberg reagent, this is a Hinsberg reagent. Okay, let us discuss something more. Let us say you are having this benzene sulfonyl chloride and we are reacting it with amines. This reagent will help us to distinguish between, we will move to the next slide. This reagent is used to distinguish between primary, secondary and tertiary amines. This is very, very important reagent, Hinsberg reagent. And how it can distinguish? This is the main scene. What we have to take? Let us take, you are having benzene sulfonyl chloride. And you are reacting with a primary amine. Let us say you are taking RNH2. So what will be the case? This nitrogen will attack over here, and this will move over here at the oxygen and will again come back releasing the chloride ion. And what will you get? You will get benzene sulfonyl, you will have amide. NH, it's NH and R over here. It means after you react with it, you will have the NH2 positive here, and the negative, the Cl negative released will take a proton it and will form a product like this. And will form a product like this. And after this, if you take a base, let us say you are taking a base, this OH negative can abstract this proton and will form an anion. And will form an anion, yes. And you will form the anionic species, or we can say that soluble species is formed. Yes, we can say that primary amine is soluble in alkalis after reaction with this, because of the presence of acidic hydrogen at this nitrogen. I hope this is clear. We will move back to the secondary amines. In the secondary amines, you will have again the benzene sulfonyl chloride reacting with, let us say, NRRH. Is this a secondary amine? Yes, this is a secondary amine. You are reacting. The lone pair will attack over here, move these pi bonds will go to the oxygen, come back again and release the Cl negative. And you will form benzene here, S double bond O, N, R, R. And you can clearly say that if you are adding up into a base over here, it will never be the solubilized. We can say that it will not solubilize. It is not soluble. Why is it so? Because this nitrogen now will not have any kind of acidic hydrogen which OH negative can abstract. So it will never be soluble in it. Is it? Okay. And if we go to the tertiary amines, let us say you are having S double bond O, Cl, let us say you are reacting with N, R, R, R. At first insight, you can pre-assume that these lone pairs can attack to this. Yes, it can. If this could be the case, what will you get? You will get S double bond O, N, R, R, R. And the positive charge is here. It means this is an electron withdrawing group, and the positive charge is present just in the neighbor of electron withdrawing group. This is extremely unstable, so it will never be formed from a tertiary. Or we can say that no reaction will undergo. No reaction will undergo in the case of 3-degree amines. Is it? So in order to summarize all, we can say that 1-degree and 2-degree amines can give Hinsberg reagent is Hinsberg reagent test. The 3-degree will not. And after doing this test, when OH negative is there, only 1-degree amine is soluble and 2-degree amine is insoluble. Or we can say that no reaction will take place. I hope this summary will help you in memorizing the whole Hinsberg reagent. I hope this is clear to you all. Okay, let us get back to the question, what is the demand of this question? We can clearly say that the compound which will not react with benzene sulfonyl chloride, we have did the entire explanation regarding it, that only 1-degree and 2-degree can react and 3-degree will not. Let us check which among the following is a 3-degree amine. We can say that this is 1-degree, This is 1 degree, this is 2 degree, and this is 3 degree. So the correct answer is third. Yes, Brotado and Pranika, absolutely correct. I hope this is clear to you all. Is this concept clear? Hi, Munna. Okay, let us move to the next conceptual part of this paper. Question number 75. We have a question number 75 which suggests that the most basic among the following in aqueous solution. Please note this word. We are dealing in a aqueous solution. This is the catch of this question, bhai. Absolutely done. Very good. And we are dealing with the basicity of amines in aqueous solution. So before dealing this concept, we will discuss each and every point regarding the basicity of amines. Starting from the vapor phase, then we will come to the aqueous phase. So that every question regarding this concept will be cleared and no more mistakes can be done. Okay, let us discuss some conceptual part. Let us say, you are taking the basicity in vapor phase. Let us say, let us check, you have taken NH3. Or you can take RNH2, or you can take R2NH, and the third one is R3N. And please clarify, guys, I'm just clarifying you that R is an electron donating group over here, not an electron withdrawing. No, Wasim, you are never be late. You can try this year. You can clearly get in selection over this. Okay, let us get back to this part. Let us see why amines are basic. Because they have a presence of lone pair, so it can donate it so that it can be basic. But when we increase the R group, or we can say that we are adding R groups, it means the electron donating groups are adding the electron density at the nitrogen center. It means R group will tends to donate its electron density to the nitrogen, so that the lone pairs of nitrogen will be reacting more basic character, will show more basic character. So we can clearly say that more will be the R group, more will be the electron donation to the nitrogen, so nitrogen can easily donate that lone pairs. So in vapor phase, the order of basicity is kind of this. This is the order of basicity. This is the order of basicity. Is it clear? This is very simplest in the vapor phase. But the trick arises in terms of aqueous solution. And what will be that case? If you are dealing in the aqueous solution, you will be having the 3 or more factors that can be correlate with each other in order to determine the basicity of amine. Let us take some examples. Let us say you have taken the NH3, or let us take the same examples. You have taken R, NH2, R, N, or H, R, N, R, are the lone pairs. You can clearly suggest me that in aqueous solution there is a presence of water molecules, and if there is a presence of water molecules. So what will be the case? It will tends to hydrogen bonded, or we can say that solvation occurs. So here the solvation energy is the dominating factor with regards to the ionize, matlab inductive effect. So we can say that in this there will be the 3 hydrogens. If we can write it in the form that hydrogen, hydrogen, hydrogen. So these nitrogen will be forming hydrogen bond with this, and you will get a cage-like structures. H. There will be the 3 hydrogen bonding in that case, and this with other OH. So it can be the case. Now, if we carry out this, this will be having the 2 hydrogens. It means it can correlate with 2 water, and here only 1 is the case, and here none will be the case. It means in that portion there will be more solvation energy which is released in order to carry out a reaction. So we can say that in aqueous solution this must be the having greater basicity, but we are lagging somewhere there. But we are somewhere lagging, because this is not only the solvation energy factor which dominates in the stability, or we can say that basicity of amines. There are other factors as well. And what are they? We can say that other factors are inductive effect as well as steric hindrance. We can say that electronic effect. Let us take an example. If you are taking CH3 and H2, CH3 ki twice NH, and you are taking CH3 twice, and this will be the case. This is primary amine, this is secondary amine, and this is tertiary amine. And if anyone will can ask you what is the basicity order in the vapor phase, you can clearly say me that this will be the order. But if we are dealing in the aqueous solution, this will not be the order. This will not be the order. So what will it be? By utilizing the solvation enthalpy and the inductive effect, the observed order is, you can remember it from WAM1, 3. And what is it? Always having the 2 degree amines at the most basic, then 1 degree amine, then 3 degree amine. M means methyl. Always remember this mnemonic, you will never get a wrong answer. This is the basicity order of methyl amines in aqueous solutions. It's M13. The 2 degrees always far better than 1 and 3. And if you are taking ethyl, if you're replacing the methyl with ethyl, let us say, just a second, you are removing this, you are replacing the methyl with ethyl, you will get an order E31. It means 2 degree amines are greater than 3 degree than 1 degree. This will be the case in this particular question. Is it clear? Is it? Okay, let's get back to the question part. And the question suggests which among the following is having the most basic amine in the aqueous solution. We have understood the whole concept regarding this, and we can clearly say that you are given the methyl groups in here. And if methyl groups are here, you have to follow M13. It means in case methyl, the 2 degree is always greater than 1 degree, then 3 degree, then amines. It's ammonia. and the order is 2 degrees greater than this. So option 2 is the correct answer. The steady empire, why not electron withdrawing groups? If you are taking the electron withdrawing groups, so why are you dealing with the basicity among this? Because if we have taken the electron withdrawing group, it means the lone pairs are already adjusting in neutralizing the electron withdrawing nature, or the electron withdrawing group will take an electron density from nitrogen, so basicity always decreases. Okay. Okay, let's move to the next conceptual portion, question number 78. This question is having a statement-wise question. There will be two statements. You need to check both of these, which is stable and which statement is correct, which one is incorrect. So, as per the statement A, benzene does not decolorize bromine water. We will see it. In statement B, phenol decolorizes bromine water. Okay, let us discuss these reactions in so much detail that you guys are much aware about the conceptual part of this. So let us discuss. Let us say you are taking the benzene and you are reacting with bromine water. What is the color of bromine water? Kind of reddish brown. It means when bromine water is added in benzene, so what will be the case? There will be the presence of pi electrons. So these bromine must be added to this and will form a cyclo, or we can say that the addition product. But there will be no reaction in this part. And why is it so? Because this benzene is an aromatic species, and when you will carry out an addition reaction to this benzene, the aromaticity loses. And if aromaticity loses, it means the compound is moving to destabilization. If the compound is moving to destabilization, it will never be the case. The compound will always try to get in stability, or we can say that to reduce the potential energy of this. So this reaction will never be the case, because addition reaction is not a case of aromatic compounds. I hope this point is clear to you all. Is it? Okay. So it means we can clearly say that if this reaction will not occur, it means the bromine water, the color will never be decolorized in this part. So never get decolorized. And in the second part, it means the statement 1 is absolutely correct. On moving to the statement B, phenol decolorizes bromine water. Let us take an example. Let us take a concept that this is phenol and you are reacting with bromine water. What will be the case? Will it decolorize it? This is again a aromatic compound. So the case will be like it will not be reacting with bromine and will not show an addition reaction with it and will not decolorize it. Is it the case? No. Here this will not be the case. And what will be the case? The electron density of this ring increases that much that because of the OH, this can increase the electron density and will attack to this bromine. And here, no addition reaction occurs. Here, substitution occurs. And what will be the case? If we can clearly say that if we are reacting with bromine, these positions, the ortho positions and the para positions were highly activated. Highly activated. It means these electrons, this electron density will attack to bromine and will form a substitution product OH, and there is a presence of bromine water. It means multi-bromination will take place, more than one bromination. You will be getting Br, Br and Br. This will be the case. It means we can say that the color of bromine water, which is reddish brown, it will decolorize here. It will, we can say that, decolorize. It will decolorize. It means option statement B is also correct. So what will be the answer? Both statement 1 and 2 are correct. So option number 1 will be the correct answer. I hope everyone have enjoyed this session. Do you guys have any kind of doubt so that we can clarify it? Is it? Okay. Let's move to some questions of aldol. I can provide you as a homework part. So you can try. In the next session, we will discuss your doubts in that question. Okay. Let us take some examples. Let us see, you have taken this. This is hydrogen. You are reacting with OH negative. What will be the case? The product. This is the question you need to attempt as your homework part. And will please give me a detailed explanation in the comment section below. Okay? Is it clear? Substitution reason है more acidic हो जाना. I'm not getting your point. I hope this class will be that much good that you'll have learned many kind of concepts. If you guys have no doubts, then we will meet you in the next session. Okay. Thank you so much for joining this class, and please study hard.